Can you feel the energy? I can. You're about to learn the intermediate value theorem. And let me just warn you, if you're in an advanced calculus AB or BC class, you have to know this. In some college courses, they require this. And in some other high school courses, they require it, but not others. So make sure that you need to know this before you go into it, or just watch it for fun. It's a very simple idea, but it basically is the beginning of what are called existence proofs that we do in mathematics. So it's a big deal in theoretical math, right? Math that sometimes applies to the real world, but not always. It's beautiful. So let's go over it. The semi-formal gist of the intermediate value theorem is this. Let's say you're given a function f of x, here's f of x, that is continuous on a closed interval. Here's the closed interval a to b. So it's continuous, no holes, jumps, or gaps. Then f of x must pass through every y value between f of a and f of b. So this right here would be the y value f of a. And the y value here would be f of b. So we're going to pass through every y value between a and b, which makes a lot of sense if you think about it. So let's pretend that you jump off a diving board into a pool. And you start out so that your head is at, I don't know, 8 feet off the water. You jump up and go into the water, which is at 0 feet. That means that at some point your head had to have been 7 feet off the water. You didn't skip through the 7 feet, right? You started at 8 feet, maybe you jumped up, we don't know how much, but you went down into 0, that's the guarantee. At some point your head had to have been at 7 feet at least once, right? And probably only once for jumping off a diving board. That's what this says. We take on every y value between our start and our finish. The key here is that the function has to be continuous for this to be true. Now the formal definition is, if f of x is continuous on the closed interval, ab, then there exists at least one number, x equals c, on the interval, a to b, such that f of c is between f of a and f of b. What does that mean? Well, that means, let's say that we see that there's got to be some point c, comma, f of c, such that f of c is between f of b, this y value, and f of a. It's that simple. You got to take on every single y value. Now, the actual problems that go with it, a little bit gnarly, but we're going to get through them together. Let's do it. So this says, state why the intermediate value theorem applies on the given interval. Then we're going to find the value x equals c guaranteed by the intermediate value theorem. Now, just to point this out, intermediate value theorem makes a lot of sense in terms of why it's called that. Intermediate means in the middle, right, or in between. So you're finding a value in between two other values, and it's a theorem, right? It's a theorem that has been proven that we use. So the only thing we have to state why the intermediate value theorem applies is we have to show that we're continuous on this interval. Well, this is a polynomial. All polynomials are continuous. You never pick up your pencil when drawing them. So I'm going to type this one out for you. You might even hear me clicking on the keyboard here. We'll say that since f of x is continuous on the interval between x equals 0 and x equals 3, the I.V.T. applies on the given interval. That's it. Very, very simple. Not so bad. At least I don't think it's so bad. Okay, so that's it. That's the premise. If your function is continuous on the interval, then we know that the intermediate value theorem applies. Now, how do we then find the value of x equals c guaranteed by the intermediate value theorem? Well, we're being told that f of c equals 3. We're told that. That's what we're saying must occur between 0 and 3. How do we know that that has to happen? Well, so I've got, since f of x is continuous on the given interval, x equals 0, x equals 3, the I.V.T. applies in the given interval. I would say, you know what, I'm going to add in something here. Since f of x is continuous, and I'm going to put something really fancy here, f of 0, well, f of 0, when we plug it in, is equal to -7, just plugging 0 into this, which is less than f of c, that's 3, which is less than, let's plug in 3. If I plug in 3, f of 3, 3 squared is 9, plus 9 is 18, minus 7 is 11. What I've done here is I've plugged in the two endpoints, and I've shown that the two y values sandwich this value, meaning 3's got to occur somewhere between -7 and 11. It's a number that happens between those two values. So f of x is continuous, and these values bookend, if you will, f of c. It's going to occur. So now all we're left to do is find what that c value is when y equals 3. So 3 equals x squared plus 9x minus 7. We set it equal because we want to know what the x value is when y is 3. And this just becomes an old algebra problem. You subtract 3, so we get x squared plus 9x minus 10. Then we're going to factor, of course. The numbers that multiply to 10 that combine to give us 9 would be, well, 10 and 1. That would be plus 10 minus 1. And we set each value equal to 0. Get x equals negative 10 or x equals 1. Now, which of those values is guaranteed by the intermediate value theorem? It's got to be on the interval from 0 to 3. So c is that x value of 1. So what we did there is we found the x value that gave us the y value of 3. And we also stated that the curve is continuous from 0 to 3. And also that these values sandwich 3. That's what all that math means. All right. Now, the final part of this video, I'm going to warn you again, is very formal. If you're in advanced calculus, A, B, or BC, or you've got a professor or teacher that's rocking this stuff hard, you'll want to look over this, or maybe just do it for fun. This says, and this is going to be a proof, given f of x is a continuous function, that's important, on the interval 0 to 8, is there a value x equals c? So is there some x value that exists on that interval such that f of c equals 12? In other words, in normal speak, is there an x value where a y value's got to equal to 12? So if we look at this table of information, there's no y value of 12. So what we need to look for is where on 0 to 8 do the numbers go from above to below 12 or from below to above 12? Negative 5 to 6, no, to 10. We still haven't gone above 12 at all. Back down to 7. Ooh! Up to 13. So since the graph goes from 7 to 13, 12 is guaranteed to happen somewhere between 5 and 6. So now we've got to somehow formalize this. How do we explain our answer? And I do it formally like this. I say since f of x is continuous, you've got to state that part. If you don't state that f of x is continuous, we cannot use this theorem. Because if it's not continuous, you could jump from one level to another and skip all these y values in between. So since f of x is continuous on 0 to 8, and now I've got to state where we sandwich the y value of 12. And I'm going to do it with that fancy inequality again. And f of 5 is equal to 7, which is less than what we want to show, f of c, which is equal to 12, which is less than f of 6, which is equal to 13. And now all you've got to state is then the intermediate value theorem, then the I.V.T, I don't typically abbreviate when I'm doing super formal, but why not right here? Then the I.V.T of the intermediate value theorem, let's see, guarantees. And now this is where I copy the question. There is a value x equals c, so there is, it's fun to watch me write, isn't it? Oh my goodness, gotta be sleeping. There is a value x equals c that exists. Just copying this right here at this point. On this interval, oh, beautiful. On this interval, such that f of c equals 12. Don't memorize how to do this. The main ideas here, people, is you've got that the function's continuous. You must state that. Then we're showing that there's two values on either side of the value that we're looking after. So it happened to be from 5 to 6. We go from 7 to 13 in the y values. So the intermediate value theorem guarantees what we wanted to guarantee. You don't have to state what the intermediate value theorem means. By showing that you understand what must be true and then using it correctly after showing evidence of where the number is sandwiched, that allows you to just state the intermediate value theorem guarantees. That's a proof. That is what is known as an existence theorem and an existence proof, because we're proving that there exists a value such that the y value is 12. We just don't know what value that is. Sweetness. See you next time.